I welcome all of you in this video, and today we will learn about exploratory data analysis. So what skills we will cover in today's session? First of all, we will see what is EDA. Then we will see some of the Python libraries like NumPy and Pandas. Then we will cover some part of statistics which will be helpful in data analysis. Later, we will do a hands-on session of exploratory data analysis. So what is EDA? Exploratory data analysis is a process of performing investigation on your data and find underlying hidden patterns. With the help of various functions and visualizations, you can also spot anomalies or outliers in your dataset. In a nutshell, we do exploratory data analysis to understand our data and gain valuable insights from it. You might be thinking that why we do EDA. We detect mistakes and missing data and anomalies during exploratory data analysis and find the relationship among exploratory variables. An example of it is, for instance, you are a farmer and you sell fruits. Somehow, you start to keep records of daily sales, and when you put these sheets together after a month, you find patterns in your sales, and based on those insights, you eventually know how to make your sales consistent, even in different seasons, and how to boost them. So data here is your fruits, and your analysis is the key that leads to success. First of all, we will see what is NumPy and its purpose. Numerical Python, popularly known as NumPy, is a core library for scientific computing. It provides high-performance multi-dimensional array objects and tools for working with these objects. Throughout this course, we will work on NumPy and see its use. We can perform many operations with the help of NumPy on data structures, such as arrays, matrices, and so on. And we will see some of them later in the course. Now let's see an example of NumPy. First of all, I will import the library by writing import NumPy as np. Then I have taken a list, and after that, I have converted the list into an array using the keyword np.array. Now let's see what is Pandas and its purpose. Panda is a data analysis library that provides a variety of data structures and data manipulation methods that allows to perform complex tasks with simple one-line commands. In today's session, we will see how the objects are defined by pandas. We will execute a series of important operations with the help of pandas. Let's see an example. So pandas has two types of data structures. First one is series. The second one is data frame. As we can see, series stores single data columns and it's one-dimensional. However, data frame consists of two-dimensional tabular data structure with labeled axes such as rows and columns. Now you might be wondering that what format of data we will use in this session and why. So first of all, let's see what a dataset is. A dataset is nothing but a tabular representation of data. Each column in dataset represents a feature or variable, and each row corresponds to a given record. We often get data in various formats such as CSV, Excel, from database, or in a JSON format. However, we will be using a structured form of data in this course, which is known as CSV. So what is CSV? CSV is simply just like an Excel file and it stores data in comma-separated values. Furthermore, they are convenient to use and export data. How a CSV looks like. As you can see, if we open a CSV file in Notepad, it looks like this. You can also see some commas here which separates the values. Let me show you. So here is a CSV file. All of these are your columns, and these are known as your variables or features. And these are the rows of your data set. Now let's have a recap of some statistics before moving to exploratory data implementation. So what is mean? Mean is the average or the most common value in a collection of numbers. For example, you have some numbers like 2 plus 6 plus 4 plus 5 plus 8. So mean is the sum of all of these numbers divided by the total number. So 25 by 5 is equal to 5. Then we have median. Median is a statistical measure that determines the meta value of a dataset listed in ascending order. So middle value in this dataset is 6, like 1, 2, 3, 1, 2, 3. On each side of 6, there are 3 values. So it means that 6 is your median. Now let's see what is mode. The mode is the number in a set of numbers that appears the most often. For example, 1, 3, 3, 3, 7, 8, and 9. 3 is the number that appears the most. So 3 is the mode. Now let's see what is range. Range is the difference between the highest value and the lowest value in a dataset. 10, 20, 30, 40, 20, 70, 60. So the highest value is 70 and the lowest value is 10. So 70 minus 10 equals to 60. So range is 60. Now let's see what is variance. A variance is a measure of how far a set of data numbers are spread out from their mean or average value. We can find the variance by just subtracting the mean value from each data point and then square it. Later, we sum all of this case and calculate the average. What is standard deviation? It shows how much your data is spread around the mean, or how much observations are around the mean. You can just take the square root of variance and it would be the standard deviation. Now it's time to move towards a hand-on session. This session involves using the measures of central tendency like mean, median, mode, standard deviation, and variance. We will also do univariate non-graphic exploratory data analysis in this video to understand the underlying sample distribution and make observations about the dataset. Now let's open the Jupyter Notebook. As you can see here, I have already created a folder for us. It's exploratory data analysis. I will just simply click on it. In this folder, I have placed the CSV file with the name of diabetes.csv. So this is our data set. I will click on New and choose the kernel Python 3. This makes a new notebook in your directory. First of all, we will change the name. EDA Part 1. From here, I will choose the markdown and put the markdown here. Importing libraries. Now in this cell, I will import the required libraries. Import numpy as np. Import pandas as pd. And run. Now I will choose another markdown and I will say read CSV. So we will load the dataset into our notebook with the help of pandas. We can name the dataset as diabetes. Now pandas has a useful function which is known as pd.readcsv to read the CSV files. Here I will write the name of that CSV file. Don't forget to write the format of the file here. As the file is CSV, so I will use comma and then read it. So this loads our CSV file into the notebook. Now we have a function known as head. Let's see what this function do. Diabetes.head. As we can see, this function print out the first top 5 rows of a dataset. As you can count 1, 2, 3, 4, and 5. The starting index is always 0, but you can change it. Now let's suppose if you want to see the top 10 rows of the dataset, then you can put the numerical value here in the head function. As you can see, it has printed the first top 10 rows. Now let's suppose if you want to see the last 5 rows, then you can use the function of tail, diabetes.tail, and run it. As you can see, this function has printed the last 5 rows of the dataset. The number 5 is by default, so whenever you use head or tail function, it will always print out the 5 rows until or unless you pass an integer value here. Now it's time to explore our dataset further. So I will write a function named as shape. Diabetes.shape. So it shows the size or the shape of our dataset. The shape is 768 rows and 9 columns. Now let's see which columns we have in our dataset. Diabetes.columns. We have columns pregnancies, glucose, blood pressure, skin thickness, and so on. Now I want to explore my dataset further. So I will write the name diabetes.info. This provides a summary of the dataset. As you can see that most of the values are integers and only 2 of the columns are floats. 7 of them are integers. Now let's suppose we want to see the statistical measures. Now let's suppose I want to see the statistical details of my dataset. Then I will write the name of the dataset dot and I will write describe. So this keyword provides you details about your dataset. For instance, you can see the mean values from here, the total number of values from the count, standard deviation, minimum value in the dataset, the first quartile, the mode or the most occurring value, the third quartile, and the maximum value. For instance, we see the column of age. I can see that the maximum age is 81 and the minimum age is 33. And 50% or most of the people, I mean the mode, has the value of 29. So it means that most of the people are having the age of 29. That's how you check and see the other columns too. Now let's suppose I want to check the number of null values in my dataset. So I will write print the number of empty values in my dataset are diabetes dot is null dot sum. So is null function is the function that calculates the null values in your dataset, and sum function sums all of those numbers. As we can see here, we don't have any null values in our dataset. All of them are 0. So it's quite good. Now let's suppose I want to check all of the duplicative values in my dataset. So I will say print the number of duplicate values are len. So you know len function counts the len. Diabetes dot duplicated. So I will call the function of duplicated. As you can see, we have 0 duplicate values in our data set. Now let's move forward. For instance, if I want to check the unique values in a column in my data set, then I will say diabetes dot, let's suppose we take the column of age. As you can see here, it's AGE, diabetes dot age dot unique. So it will show all of the unique values in the column age. Now, for instance, I want to see that how much values a specific age has. Then I will say diabetes dot age dot value counts. So it's in front of you. 22 age has the count of 72. 21 has the count of 16.3, and so on. Now let's suppose I want to see the correlation of variables. Then I will write diabetes.core. So core is an abbreviation for correlation. Correlation values are between -1 to 1. If a value is towards +1, it means a positive correlation. If a value is towards -1, it means a negative correlation. Let's suppose that we have a variable outcome and we want to see that what correlation this variable has with other variables. So outcome represents if a person has diabetes or not. Now let's see the relation of outcome with age. It's 0.23. It's a positive correlation. Now let's see the relation of diabetes pedigree function with outcome. It's 0.17. It's also a positive correlation. Now let's see the variable which has the least correlation. It's insulin. Insulin has a value of 0.1. So this means that insulin does not have a good correlation with outcome variable. So we have finished the work for this video. Let's summarize what you have learned today. You have learned how to load a dataset into your integrated development environment. You have learned how to read a CSV file. Also, you have learned how to use head function and what do we do with head function. You have seen how to see metrics of dataset by using the syntax of describe. You have seen how to find the null values. You have also learned how to find the duplicates in a dataset. You have also done descriptive analysis. Now you have a little homework to do. Here is the link of the dataset. All you have to do is to just create an account and download the dataset. Now these are the homework instructions. You have to find the data type of variables. Also the number of missing values in each column. Also find the number of duplicates and do some descriptive analysis. So this is the end of this video. See you next time.